Estimating the electrical work for a large residential project, especially one around 8,000 square feet, requires careful consideration of several factors that may not be as critical in smaller homes. Firstly, accurate load calculations are essential. This involves not only the existing plans, but also anticipating potential future needs. Remember that initial plans are often incomplete, especially regarding convenience receptacles and exterior lighting. A detailed room-by-room analysis, including appliance circuits, lighting, and general-purpose circuits, is crucial. Pay close attention to the National Electrical Code requirements for calculating general lighting loads, small appliance branch circuits, and laundry circuits. Don't forget to factor in the loads for large appliances such as refrigerators, ovens, dishwashers, washing machines, and dryers. The NEC provides specific methods for calculating these loads, including demand factors that allow you to reduce the calculated load based on the likelihood of simultaneous use. Secondly, voltage drop becomes a more significant concern in larger homes due to the longer circuit runs. Voltage drop occurs when the voltage at the end of a circuit is lower than the voltage at the source. Excessive voltage drop can cause lights to dim, appliances to malfunction, and motors to overheat. The NEC sets limits on the allowable voltage drop for branch circuits and feeders. To minimize voltage drop, use appropriately sized conductors. Larger conductors have lower resistance and therefore less voltage drop. You can use voltage drop calculators or consult NEC tables to determine the appropriate conductor size for a given circuit length and load. Consider using home runs for critical circuits or areas with high power demands. Thirdly, service sizing is paramount. A 320 amp service is a reasonable starting point for an 8,000 square foot home, but it's vital to verify that it is adequate for the calculated load. Overestimating the load is always preferable to underestimating it. In addition to the general lighting and appliance loads, consider the loads for any specialty equipment such as swimming pools, hot tubs, electric vehicle chargers, or backup generators. Ensure that the service entrance equipment, including the meter socket, service conductors, and main overcurrent protection device, is properly sized for the calculated load. Also verify the local utilities requirements for service connections and metering. Fourthly, panel board selection and distribution are critical. The plan includes a 200 amp main breaker panel at the meter pan, a 200 amp distribution subpanel fed from the main panel, and a 100 amp subpanel fed from one of the 200 amp panels. This configuration is a good starting point, but you may need to add additional subpanels depending on the layout of the home and the distribution of electrical loads. Locate subpanels strategically to minimize circuit lengths and reduce voltage drop. Consider using a combination of main lug only and main breaker panels depending on the specific application. Also, plan for future expansion. Include spare capacity in each panel board to accommodate future circuits. It is much easier and less expensive to install extra breaker spaces during the initial installation than to add them later. Fifthly, lighting control is an area where significant advancements have been made in recent years. With 120 recessed lights already planned, consider incorporating a lighting control system. These systems allow you to control multiple lights from a central location, create lighting scenes, and even integrate with home automation systems. Lighting control systems can improve energy efficiency, enhance security, and provide greater convenience. Consider dimming controls for recessed lights to allow homeowners to adjust the brightness and create different moods. Also, consider using LED lighting, which is more energy efficient and longer lasting than traditional incandescent or halogen lighting. Sixthly, grounding and bonding are essential for electrical safety. Ensure that the grounding system is properly installed and connected to all metal enclosures, equipment, and appliances. Use a ground fault circuit interrupter, or GFCI, protection in all wet locations such as bathrooms, kitchens, and outdoor areas. Also, consider using arc fault circuit interrupter, or FSI, protection for branch circuits that serve bedrooms, living rooms, and other areas where arc faults are more likely to occur. Seventhly, communication and low voltage systems are often integrated into modern homes. Consider including wiring for data, telephone, and cable television. Also, consider wiring for security systems, home automation systems, and audio/video systems. Work with qualified contractors to design and install these systems. Eighthly, exterior lighting is an important consideration, even though it is not included in the initial plans. Exterior lighting can enhance security, improve aesthetics, and provide safety for walkways and driveways. Consider using photocells or timers to control exterior lighting automatically. Also, consider using motion sensors to activate lights when someone approaches the property. Ninthly, code compliance is paramount. Ensure that all electrical work complies with the latest edition of the National Electrical Code and any local codes or regulations. Obtain all necessary permits and inspections. Work with a qualified electrical inspector to ensure that the installation meets all applicable requirements. Tenthly, documentation is critical. Keep accurate records of all electrical work, including wiring diagrams, panel schedules, and test results. This documentation will be helpful for future maintenance, troubleshooting, and modifications. Provide a homeowner with a complete set of as-built drawings and a detailed explanation of the electrical system. 11thly, consider surge protection. Whole house surge protection at the main panel and point of view surge protection sensitive electronic equipment is a wise investment. Surges can damage or destroy electronic equipment, and surge protection can help to prevent these losses. 12thly, think about energy efficiency. Encourage the homeowner to use energy-efficient appliances, lighting, and HVAC systems. Consider installing smart thermostats and energy monitoring systems to help the homeowner manage their energy consumption. 14thly, future-proofing is crucial. Technology is constantly evolving, so it's important to plan for future needs. Consider running extra conduit or installing empty junction boxes to accommodate future wiring. Also, consider using flexible wiring methods that can be easily modified or upgraded. 15th, coordination with other trades is essential. Electrical work often needs to be coordinated with other trades such as plumbers, HVAC contractors, and carpenters. Communicate with these trades to ensure that the electrical work is properly integrated with the other building systems. 16th, accessibility is important. Ensure that all electrical equipment is easily accessible for maintenance and repairs. Locate panel boards in accessible locations and provide adequate clearance around electrical equipment. 17th, labeling is critical. Label all circuits, panels, and equipment clearly and accurately. Use permanent labels that are resistant to fading or damage. Labeling will help to prevent confusion and errors during future maintenance and troubleshooting. 18th, safety is always the top priority. Follow all safety precautions when working with electricity. De-energize circuits before working on them, use appropriate personal protective equipment, and never work alone. 19th, consider a backup power system. A backup generator or battery backup system can provide power during outages. This can be especially important for critical loads such as refrigerators, medical equipment, and security systems. 20th, think about home automation. Home automation systems can control lighting, HVAC, security, and other building systems. These systems can improve energy efficiency, enhance security, and provide greater convenience. 21st, include detailed specifications. Provide a detailed written specification that outlines all of the electrical work to be performed, including materials, methods, and quality standards. This specification will help to ensure that all bidders are bidding on the same scope of work and that the finished product meets the homeowner's expectations. 22nd, consider submetering. Submetering allows you to measure the energy consumption of individual circuits or appliances. This can be helpful for identifying energy hogs and for allocating energy costs in multi-tenant buildings. 23rd, address any special needs. Consider any special needs of the homeowner, such as accessibility requirements or medical conditions that require specific electrical equipment. 24th, provide a warranty. Offer a warranty on all electrical work to protect the homeowner against defects in materials or workmanship. This warranty will give the homeowner peace of mind and demonstrate your commitment to quality. 25th. Plan for inspections. Schedule inspections at appropriate stages of the project to ensure that the electrical work meets code requirements and is installed correctly. 26. Obtain necessary permits. Obtain all necessary permits before starting any electrical work. This will help to ensure that the work is done legally and safely. 27th. Use qualified personnel. Use qualified electricians and contractors to perform all electrical work. This will help to ensure that the work is done correctly and safely. 28th. Document changes. Document any changes to the electrical plans or specifications. This will help to ensure that the as-built drawings are accurate and up to date. 29th. Communicate effectively. Communicate effectively with the homeowner, the general contractor, and other trades. This will help to ensure that the project runs smoothly and that everyone is on the same page. 30th. Maintain a clean work site. Maintain a clean and organized work site. This will help to prevent accidents and ensure that the work is done efficiently. Consider the placement of the recessed lights and their effect on ceiling joists and other obstructions. Remember that simply tallying up the number of recessed lights is not enough. It's important to consider the physical placement of the lights and the potential for conflicts with other building components. Also, a house of this size may warrant more than one dedicated home run back to a subpole for sensitive electronics. For instance, the home entertainment center may need a dedicated circuit with a higher amperage. Remember to discuss future upgrade plans.